Now that we understand how a traditional power plant works, we can look at some additional sources of renewable energy, and one of them we're going to look at is called biomass. Now, biomass comes in many different forms, but essentially it's fast-growing crops that can be burnt in order to produce energy. So these are crops that are not grown for other purposes, they're grown specifically for producing energy, and they're fast-growing crops. Now, another advantage of burning these crops rather than burning coal is that they're carbon neutral. Now, what do we mean by carbon neutral? Well, when we burn these crops, they're still going to produce carbon dioxide. And one of the reasons we don't want to continue burning coal is because we don't want to pollute the atmosphere. But the difference here is the fast-growing crops absorb CO2. So the crops themselves use CO2 for respiration. Now, what we mean by carbon neutral is the amount of carbon dioxide they produce when they're combusted equals the amount of carbon dioxide they absorb when they grow. Therefore, the two balance or cancel out, so we don't have those harmful effects to the environment. The other reason we don't want to continue burning coal is because it's running out, and the coal that we're burning was formed hundreds of thousands, if not millions of years ago. So unfortunately, it's not going to replenish at the same rate that we're using it. The difference with our biomass fuel is that we are able to produce it at the same rate that we're using it. Therefore, it's considered renewable or sustainable energy. Now let's take a look at the process. So the first difference is that instead of burning coal, we're burning our biomass fuel here on the left-hand side. But the combustion process is exactly the same. We're burning the fuel, and we have a heat exchange between cold water entering the boiler and superheated steam leaving the boiler. And the rest of the process is exactly the same because our superheated steam passes through a turbine and it loses its energy, or it gives up that energy to produce mechanical work, and then that mechanical work is used to turn the rotor in our generator. The generated electricity is then fed into the national grid. Now, to ensure that we absorb sufficient energy within our turbine, what we actually do is we feed the steam into a condenser. And a condenser is designed to condense the steam or turn it back into water. So although we've expanded the steam and we've extracted the energy in order to turn our generator, we're still going to have steam exiting the turbine. It's going to be at a lower temperature and a lower pressure, but we still have steam. We need to pass it through our condenser, which we see positioned at the bottom here, in order to turn it back to water, exiting the condenser. So what we're actually doing there is extracting more energy from the steam, but what we don't want to do is waste that energy. Now, in this particular system, the way that they use that energy is by heating up a second water supply. Now, this water is used for what we call district heating. And all we mean by a district heating network is that hot water exiting our condenser can be used for other purposes, such as heating buildings and so on. And all district heating is a way of storing that hot water centrally. So we may have a village or a town that operates on district heating. That would mean that each individual building wouldn't need its own boiler system. Instead, the buildings would use the hot water from the central reserve. So we can see that that's a secondary benefit. Not only are we producing our electricity, but we're also able to provide hot water for heating systems.